Hello, this is Math Jazz from Almost Cool, and I am here with a live stream. Now, this is the beginning of most people's semesters, and I didn't get many emails, well, I didn't get any emails this week, but I expect that to change in the future. Right now, um, I have some U substitution problems that we're going to work through, and I show you them to you now. So here are the Oh, I forgot to rename the live stream. I'm sorry, it says Tom Clancy's Splinter Cell. But that'll be corrected in the YouTube recording after the live stream is over. Anyway, we have these 4 problems that I'm going to do for you, and they're just simple U substitution problems. We'll take the first one a little slowly because it's probably been a while since you've done much calculus. And if you have any questions, ask me and I will answer them. So, problem 1a. We have the integral of 2x times x minus 3 squared, and we're integrating that with respect to x. So we notice that we have the product of 2x and x minus 3 squared, and that x minus 3 squared is a composition of functions. The outside function is x squared, the inside function is x minus 3. When you have this type of a pattern, you're going to let u equal the inside function on the composition. So we're going to let u equal x minus 3. This, of course, means that du is equal to dx because constants die under derivation. So we're going to substitute these into the original expression. U is x minus 3 and du equals dx. And we obtain the integral of 2x times u squared du. But we're not done. We have this extra x sitting around, and we need to get rid of it. The way to get rid of it is we're going to manipulate our u substitution, solving for x so that we can replace the x in our integrand. So we get x is equal to u plus 3, we substitute, and we get 2 times u plus 3 times u squared du. And that gives us a nice polynomial that we can evaluate with the power rule for integration, and we get 1/2 u to the 4th plus 2u cubed plus c as our antiderivative. But again, we're not done. We have to convert back into an x expression because our original problem was stated in x's, and we can't give our antiderivative in u's. Substituting back, we get 1/2 of x minus 3 to the 4th plus 2 times x minus 3 cubed plus c. That's our first problem. Our second problem, we have the integral of sine x times the square root of 3 plus cosine x with respect to x. So we let u equal 3 plus cosine x, du equals negative sine x dx, and with that we substitute to get the negative integral of the square root of u with respect to u. We use the power rule on this, and then we substitute back into x, getting negative 2/3 times 3 plus cosine x raised to the 3/2 power plus a constant c. Problem 1c. The integral of 2 times e to the sine squared x times sine of x times cosine of x with respect to dx. We're going to let u equal our interior function sine squared x, which makes du equal to 2 sine x cosine x dx. We make our substitutions, getting the integral of e to the u du. The antiderivative of e to the u is itself plus an arbitrary constant. And then we substitute back into x's to get e to the sine squared x plus c. And our final problem for the day will be the integral of x ln of x squared plus 1 with respect to x. We let u be our interior function, x squared plus 1, du equal 2x dx. Then we do our substitution, which I guess I didn't quite type in, but we get 1/2 of the natural log of u du. Oh no, the middle step here is us giving a 2x, giving a 2 to the integrand so that we can substitute for our du, and balancing that 2 with a 1/2. See, 2 times a half is 1, so we didn't change the value of the expression. There we go. So now we get our u integral, and then we take our antiderivative of the natural log of u, getting u ln of u minus u plus a constant. We substitute back into x's, getting x squared plus 1 times the natural log of x squared plus 1 minus x squared minus 1 plus our arbitrary constant c. And, I mean, in all honesty, we can suck this -1 into our arbitrary constant c. And I didn't write that in, but we could. Oh no, I did. Here it is. So this -1 gets combined with our arbitrary constant as so. I hope you enjoyed the live stream. Please send your questions via email to mathjazz9@gmail.com or ask them in the chat during the live stream, which happens every week at this time, which is 5 p.m. Pacific time. And I hope that you all have a great week. See you next time. Bye.